Okay, quick video on conduction system disturbances, or basically bundle branch blocks. We'll talk about some basics here, some specifics, and then I'm going to show you kind of the down and dirty version of figuring this thing out. So by definition, number one, bundle branch blocks. QRS is complex with a bizarre appearance. Hang on, let me get my page here right. I'm out of order. Anyways, that is has a bizarre appearance and longer than 0.12. So it needs to be longer than 0.12 for it to be labeled a bundle branch block. That is one of the specifics, because otherwise then everything is operating as it should be, and there's not going to be any issues, right? So with a right bundle branch block, you have a terminal R wave in lead V1. Now what we're going to, and you also see a terminal S wave in leads 1, AVL, and V6. So the terminal being the last wave of the QRS. So what we're going to mainly look at, though, is this right here. We're going to look at V1. So we're going to look at V1 to determine left bundle branch block or right bundle branch block. So knowing that we have a terminal R wave in lead V1, and I'm going to go ahead and show you the left so we can talk about this as a whole. When we talk about a left bundle branch block, we're going to look for a terminal S wave in lead V1. Once again, we're just going to focus on V1. So let me show you kind of a quick, down and dirty, easy way to figure this out. So what we're going to do is, and I am not good at coloring with this thing, so be nice to me, is number one, we're going to go up here to V1. We're at V1, right? So we're going to start taking a look at our EKG here. And first thing we're going to do is we're going to go to our J point. You guys should remember that. Our J point is basically where the QRS ends and the ST begins. So let's just call it right here. Now what we're going to do is we're going to color this in. So we go back to our first line and just color that in, okay? Now we see that we've moved up. Many of you may already know this method, but what we're going to do is this is going to be the turn signal method. Now, think about that you're driving your car and you're going to use your turn signal to let the person know which way you're going. As you can see here, we're going up, so you flip your turn signal up, and that means you're going to be turning where? Right. This is a right bundle branch block, going from your J point back and coloring that in, and depending upon the direction that we colored is the direction of the bundle branch block. So by definition, we see we have terminal R wave in lead V1, and we have that, see our R wave up here, as well as we're going to go back and up. So once again, just another way to do that. In my opinion, it's a little easier. Let's take a look at another one. So here we go. Okay, a little midstream adjustment here. So if it sounds sketchy, it's all right. So looking at this one, we know here's our QRS. We're going to get into our ST segment here. So where the QRS ends and the ST segment begins is where we're looking for. That's going to be our J point. We're going to go back, and you see here, we're going to be coloring down. So in your car, if you push your turn signal down, you're going to be turning left. So once again, J point backwards, meaning this way backwards, and then if you go up, it's going to be turning right. If you go down, you're going to be turning left. That's a quick and simple way. You're more than welcome to remember these rules, being a terminal S wave in lead V1 and a terminal R wave in lead V1. But this is a easier way. Now remember, you also have to have this. So you have to have 0.12 or greater of QRS for that to work as your to figure this thing out. So that real quick, conduction system disturbances, talking about bundle branch blocks.